everyone. I, Professor Bhavik Kumar M. Kataria, welcomes you into the video series of operating system, and we are discussing unit number 2, that is process management. Before today, in our earlier session, we have discussed first come first serve process or CPU scheduling. So guys, if you are still remain to watch our earlier video, so you can click on I button at top right corner and you can watch earlier session. Let's start discussing today's session, that is all about shortest job first algorithm. Let's see what about the shortest job first scheduling. So as per our earlier session about first come first serve scheduling, that was a non-preemptive scheduling. Same case here in terms of SJF scheduling. SJF is also non-preemptive type scheduling algorithm. As per our earlier discussion, in case of preemptive mode, we can stop the process in between the execution, whereas in case of non-preemptive mode, we can't stop any process in between the execution. Second thing, that is a criteria. If we will look about the earlier session, first come first scheduling, so that was followed by the arrival time, whereas in today's case we are discussing SJF scheduling, so it is following the criteria of burst time. It means whatever the process have a shortest burst time, that process will serve first. Let's see with the example so you can imagine in better way. Here data given to us, there are 5 number of processes P1, P2, P3, P4 and P5. Arrival time available for the all 5 processes and burst time available for all 5 processes. So two parameters given here, arrival time and burst time. Now criteria is burst time. It means which process have a smaller burst time, that process will execute first. It means if we will compare all 5 processes, so P3 have a smaller burst time. So whatever the process have a smaller burst time, that process can execute first. And we have to find out average turnaround time and average waiting time. So let's start calculating example. First we are putting values which is given us into the data. 5 different processes, arrival time of all 5 processes and burst time of all 5 processes. For finding the completion time of all processes, there is need to draw a Gantt chart. As per our discussion in earlier session, we are starting Gantt chart always from arrival time 0. So we will start drawing Gantt chart from time 0. But if we will look about the arrival time of all processes, so no process has arrived at arrival time 0. First process arrived, that is at arrival time 1. But we are going to start our Gantt chart from time 0. So from time 0 to 1, there is no process which is in execution. Get it? So always in terms of process scheduling, we will start drawing Gantt chart from time 0. If any process arrived at arrival time 0, then we can start executing that process. Otherwise, we have to wait till the arriving of process. Right now at a arrival time 1, process P1 is arriving and process P1 have a burst time 7 millisecond. All timings given to us, that is in millisecond. So if you will look here, our criteria is burst time and we have to choose that process, which process have a smaller burst time. But at a arrival time 1, if you will look, so there is no need to compare P1 with any other process, because P2, P3 and P4 have a smaller burst time as compared to B1. But right now at arrival time 1, only process P1 is arrived. So we have to start executing P1 only. There is no need to compare burst time of P1 with any other processes. So let's start executing process P1. And after starting the execution, P1 will complete their entire execution because mode is non-preemptive scheduling. So we will allow process P1 for the 7 time units, and 7 time unit is a burst time of process P1. So after 7 millisecond, process P1 will complete their execution. So completion time will be 1 plus 7 is equal to 8. So we will note down the completion time of process P1. But up to the 8 millisecond, all number of process arrived. Like P2 arrived at 2 millisecond, P3 arrived at 3 millisecond, P4 arrived at 4 millisecond, and P5 arrived at 5 millisecond. But we do not start the P2, P3, P4 and P5's execution because at that time P1 was in execution. So that's why P2, P3, P4 and P5 was in waiting. And these all 4 processes are ready to execute. Get it? Now at a time unit 8 or 8 millisecond, we have a 4 processes P2, P3, P4 and P5, and all are ready to execute. So which process will execute? So we will decide that according to burst time. Out of these 4 processes, whatever the process have a smaller burst time, that process will execute first. So in terms of P2, P3, P4 and P5, P3 have a smaller burst time, that is 1 millisecond. So next process will execute, that is process P3. So let's start drawing Gantt chart. P3 will execute for the 1 millisecond. So completion time of P3 will become 8 plus 1 is equal to 9. And we will note down the completion time of P3. Now, 3 processes are remain to execute, that is P2, P4 and P5. If we will compare burst time of all these 3 processes, so P4 have a smaller burst time, that is 2 millisecond. So next P4 will execute and P4 will complete their execution at completion time 11. So completion time we will note down into the table. Now P2 and P5 remain. So first P2 have a smaller burst time, and then after in last P5 will execute. So let executing P2 will complete at 16. We will note down the completion time, and then after P5 will execute. Draw Gantt chart for P5, and P5 will complete at 24. So now we have a completion time for all 5 processes. So after note down the completion time, we are able to find the turnaround time, because equation of turnaround time, that is completion time minus arrival time. So for the P1 we will get 8 minus 1 is equal to 7. For the P2 we will get 16 minus 2 is equal to 14, and same for the P3, P4 and P5. So let put the turnaround time for all processes. Next we will find waiting time, equation of waiting time, that is turnaround time minus burst time. Get it? So if we will find waiting time, so waiting time for P1, that is 7 minus 7 is equal to 0. Get it? So if we will compare waiting time with the Gantt chart, so P1 was arrived at 1 and P1 get the CPU at arrival time 1. So there is no waiting for P1. So waiting time is 0. But if we will compare process P2, get it? If you forgot the equation of waiting time, right now it is written turnaround time minus burst time, but that you have to remain in your mind, and suppose you are going to forget. So look about the Gantt chart. If we will look about the P2, so P2 was arrived at arrival time 2. Get it? And what is the time where P2 start their execution? P2 started their execution at 11. Get it? So what is the waiting time? So if you will subtract arrival time from the starting time, 11 minus 2, so you will get 9. So same thing, if we will look about the equation turnaround time minus burst time. So turnaround time is 14 and burst time is 5. 14 minus 5, same. Answer is 9. Get it? So you can find the waiting time in both way, whatever you like. So let put the value of waiting time for all processes. Hope you are understanding how to find out completion time, turnaround time and waiting time. Still, if you have any query in your mind, so you can write your question into the comment box. I will try my best to answer your queries. That is the image of food court A2B restaurant. If you will travel up to the Bangalore or surrounding areas of Bangalore or nearby cities of Bangalore, so you can visit the A2B restaurant that I like most. Here I am not doing any type of advertisement, but most of the Gujarati peoples are looking for the Gujarati taste. It is not surety you will get the Gujarati taste or not, but you will get nearby taste. And most of the IT peoples are visiting Bangalore and nearby cities frequently. So let's start again. We have to find out average turnaround time and average waiting time. For the average turnaround time, we will make summation of turnaround time, all 5 values, and we will divide it by the total number of processes. Total number of processes are 5. So make the summation of all individual values and divide it by the 5. So you will get total average turnaround time, that is 10.6 millisecond. Same thing for the average waiting time. Make the summation of individual values of waiting time and divide it by the total number of processes, that is 5, and you will get the answer 6 millisecond. Get it? In our next session, we will discuss next algorithm, that is priority scheduling. Priority scheduling is working in both the mode, preemptive mode as well as non-preemptive mode.